In this section, we're going to solve trig equations. So you're going to use the unit circle a lot. So the first one, find the degree measure of the angles between 0 and 360 degrees whose cosine is root 2 over 2. So you have to be familiar enough with the unit circle to know that if cosine is root 2 over 2, cosine is x, it must mean that we're going to be in the first and fourth quadrants. So you have to think of angle measures where the ratio is going to be root 2 over 2. So you should be thinking of 45, 45, 90. So you can have a 45, 45, 90 at 45 degrees over here in the first quadrant and 45 degrees over here in the fourth quadrant. So one answer is going to be 45 degrees. And the other answer, remember, it's not going to be negative 35. We need to have a positive degrees, is going to be 315 degrees. So there can be more than one answer for these. Number 2, find the measure in degrees of all the angles with the given cosines. So with negative 1/2, we're talking about being in the second and third quadrant where the x is negative 1/2. And if you're familiar with the unit circle, this is going to make a 60-degree triangle, which means the angle is going to be 120 degrees, but cosine is also negative 1/2 down here where this reference triangle is 120 degrees. So this is going to be 180 plus 60, which is 240 degrees. So we have two answers. The cosine of root 3 over 2, so it's positive, so cosine's positive in the first and fourth quadrant. So root 3 over 2 is from a 30-degree angle. So it's positive 30 degrees, and you're going to go all the way around and end up here, so you're 30 degrees short of 360 degrees. So you're going to have 30 degrees and 330 degrees. And then where is cosine equal to negative root 2 over 2? Well, it's negative, so cosine is negative in the second and third quadrants. And root 2 over 2 should get you thinking about a 45, 45, 90. So to get this to be a 45-degree angle, this angle must be 135 degrees. And if I need to get a 45 down here, this angle needs to be 180 plus 45. So this is 225 degrees. The same goes for radians too. These are in degrees, so you'll have to work also with radians. Number 3, find the measures of all angles whose sine is 1. We're still going from 0 to 360 degrees. So if you think of the unit circle, sine is the y value. So right here is 1, 0. Right here is 0, 1. Negative 1, 0. And 0, negative 1. So the sine is 1 at 90 degrees. But in this problem, actually, it doesn't specify where we're having 0 to 360. Actually, let's go back, because number 1 is the only one where it specifies between 0 and 360. I was thinking all of them were, but so let's go back to number 2. This is for all the angles, all angles. So we're not just talking about between 0 and 360. So in this case, we're going to have to go around, and you could go around again and stop. So you could go around once, and then again. So there's going to be so many answers. So you could go 120 plus 360, or you could go 120 plus 360 plus 360. You could do 120 plus 360 plus 360 plus 360. You could keep going. So we're going to call this, to add all the angles, we're going to write that the answer is 120 degrees plus 360 times n, whereas the n is the number of times you go around. And then another answer would be 240 degrees plus 360 times n. So each one of these you could keep adding on. So this is 30 degrees plus 360 times n. So you need to add that part if it reads all the angles. So 330 plus 360 times n. And I could do it for the last one too. So this one's going to be 90 plus 360 degrees times n. So I need to look at that for the same thing with 4, except for 4 reads find all radian measures. So this is, we're going to put this in terms of pi. So 2.5 is 5/2. So this is not coming to me exact value-wise for tangent. So I'm going to, same with this one down here, you're going to have to use your calculator. So what you're going to do is you're trying to figure out the angle. So I'm going to do the tangent inverse of 5/2, and you need to make sure your calculator is in radians. So change your calculator radian mode. So when I do that on my calculator, I get about, depending how you round, I'm going to round to the nearest tenth, 1.2. But I have to really think about the tangent here, where it's going to be positive. So if I draw the coordinate, or the 4 quadrants, tangent is going to be positive in this quadrant because the sine divided by the cosine is positive, because sine's positive and cosine's positive. Over here, tangent is going to be negative because the cosine's going to be negative and the sine's positive. So remember, a positive divided by a negative is a negative. Right here, sine and cosine are both negative, so therefore tangent's going to be positive right here. So if I'm in the first quadrant right here, I'm getting my angle in the first quadrant. To get the exact same value over here, what would I need to do? Well, I need to move around half the circle. So I'm not going to go all the way around. I'm going to go halfway around. We know that all the way around the unit circle is 2 pi, but I'm just going half of it. So this means that all the radian measures are going to be approximately equal to 1.2 plus pi times the number of times you go around the circle. So one answer is 1.2. Then if we add pi, we're going to be up here. If we add pi again, we're going to be right here, again right here. So we're getting all of the radian measures for which the tangent is 2.5. So number 5, find all radian measures. Find the radian measures of all the angles whose sine is negative 7.73. So make sure your calculator is in radian mode again. So I'm going to do inverse sine of negative 0.73. And in my calculator, I get about negative 0.8. So this all comes up to how you round again. So where is sine negative? Well, sine is the y, so that's negative in the 3rd and 4th quadrant. So I'm just, for right now, getting this angle. So this right here is about negative 0.8 radians down here. So sine is also negative right here. So somehow I need to get this other angle. So this other angle is not going to be if I add pi, because if I add pi, it's halfway around, it would be over here. It's not going to get it to this red part if I add 2 pi. So what I have to do is, I have to get to this, what I'm going to do is I have to take positive 0.8. Actually, I'm going to keep this one as around the nearest 100th with this. So this was so if I take positive 0.82, I'm going to be left with right here. So now I can get all the way around to this spot if I just add pi. So I was at the negative part, but I reflected across the x-axis to get to the positive part. And then I'm going to add pi in order to get over here. So one of my answers can be found by doing negative 0.82 plus 2 pi. So this is start right here, start at negative 0.82 radians and add 2 pi and add 2 pi and add 2 pi. Keep going. The other one is I'm going to try to get to this red part. So to get to the red, what I need to do is I need to do 0.82 approximately, or whatever. You could hold this in your calculator, and you're going to add a pi. So if I start at 0.82 and I add pi, I'm going to end up over here. Well, that number in my calculator is approximately equal to 3.96. So this is 3.96 radians over here. From here to here is 3.96 because it's 0.82 plus pi. So now the other angles with whose sign is negative 7.3 is 3.96 plus 2 pi n. Oops, noticed I forgot to put an n right here. So the two solutions are this and this. So this means this first part means let's start at negative 0.82 and keep adding 2 pi times the number of times you're going to go around. So if you go once, if you go twice. And the other number we had to get by starting at 0.82, we reflected across the x-axis and added pi.